Good evening. Hi, I don't know who's out there. This is a very strange way to do a presentation and to not really see or know who's in the room. My name's Neal. I am the Deputy Manager of the Rivers team for Shropshire Wildlife Trust, amongst other things. And my principal job is working on a project called Slow to Flow in the Corvedale. And this is a natural flood management project. I'm going to do my very best. I'm going to talk you through this presentation that I've got prepared. It's hopefully take about 20 minutes. It is very strange delivering to a room full of people who I can't see, so I hope that you find it informative and useful. And let's see how it goes. So I'm going to begin by sharing my slideshow, so hopefully the technology won't defeat me, and I'll keep talking as we go. So as I said, my name is Neal. Slow the Flow is a natural flood management project, and it's funded partly by the RFCC, and it's a partnership project with Shropshire Council and delivered also with the Environment Agency. So what's it all about? Essentially, flooding is a really big issue these days, and it costs us a huge amount of money. However, it's not always appropriate to get involved with sort of concrete, hard flood defence schemes. The photo you can see now is actually the Burway Bridge in Ludlow, and that house was completely destroyed and is no longer there. If you go there, it's a particularly large bridge, and it was caused by flooding from the River Corve near to the confluence in Ludlow. Then there's also localised flooding in small villages. So you can see now images of Colmington in 2007 and Bourton, which is near to Much Wenlock, in 2008. And these events are very sudden sort of flash flood events. The river will come up and drop down in a matter of hours, but you can see from the photographs it can cause an awful lot of damage and even be a risk to life in some cases. But when we think about flooding, we don't necessarily immediately think that it's the sort of thing that the Wildlife Trust might be interested in. However, flooding is brought about by all sorts of changes in the natural environment, and it also leads to other effects within the natural environment and the water environment. So you can see there from the list, when we've got these increased surface flows, it's also picking up anything that might be on the land. And so that can be phosphates and nitrates, which are fertilizer from agriculture, pesticides and herbicides. It can be diseases from livestock animals. Cryptosporidium is one of those. Also, they're veterinary drugs that you find in their excretions. The force of the water travelling down the river itself will cause erosion as well as taking erosion and soil actually from the fields themselves before it reaches the brook. And now this can be seen quite startlingly when you look at the next image I'll just show you in one moment. This loss of topsoil is actually hugely costly to us as a nation, and can be hugely damaging to rivers and the wildlife. So what happens is the rain lands on fields. Some of these fields can be bare and have no cover crops, particularly things like maize and potatoes in the winter or the autumn. Fields are underdrained, and these lead to our watercourses. And this is a photograph of a watercourse you can see is very brown. It's carrying quite a heavy sediment load. And then you can actually see, hoping my pointer might work. Oh yeah, so you can actually see, if I'm using this laser pointer here, you can see down the Avon estuary, you can see this brown plume, and that's soil. And also around the Thames estuary, around here, you can see these big brown plumes coming from actually all of the major rivers in the UK. And every storm event, you can take a satellite image like this and you can see the quantities of topsoil that are being eroded from the land, transported by ditches, rivers, leading out to sea, and actually creating these huge plumes. So it's a very significant amount of soil that we're losing from the land. And therefore, the sediment is the bit that you can see. Attached to that sediment are all the other sort of pollutants and other problems that you've got. I wanted to just make a sort of note. One of the other costs about this sort of pollution. So I mentioned, and that's when excretions from animals in particular, but it can also come from sewage farms, gets into watercourses, and it can give you really unpleasant, gastrointestinal infections. And this has huge cost implications for water companies. And we all pay our rates. Ultimately those costs are passed on to the customers, which is us. And there have been several repeated examples of groundwater sources being contaminated, being closed, of water companies inadvertently poisoning their customers in effect, and then the quantities of money that they have to spend in order to keep these diseases and infections out of our drinking water supply. So there's much more of a thinking these days that it's more cost effective to prevent that getting into the supply than it is to clean it up afterwards. And you can see some of the money involved there. 189 million pounds removing nitrates, for example. 92 million pounds removing pesticides from water supplies. These are big sums of money. So why is it that we are seeing increased and faster erosion and runoff now, when we sort of maybe didn't see that before, in years before? And there's a number of factors that have come together to really work together and create this situation. So the first thing that we're seeing is we are seeing more often intense rainfall events caused by climate change. So in actual fact, I'm sitting here today, it's a sweltering hot day. We had an absolutely enormous storm pass through last night. We know that that's caused localised flooding in all sorts of parts of the country. There's likely to be another series of storms. And a lot of the flooding images that I showed you in the Corvedale, in fact, are summer flooding, and they're caused by these sudden flash flood events caused by very local storms. So it's not always the river coming up after weeks and weeks of rain, although, of course, that can also be a problem. Then the other thing that we've been doing for very, very many years is we've been encouraging farmers to drain the land better and better in order to increase productivity. So we've been clearing watercourses, straightening watercourses, building more and more ditches. And now we're to the point where about 25% of the surface area of England is in fact underdrained, which is a huge proportion. And this all has the effect of hurrying water off the land and downstream, so it arrives in problem locations all together, all at the same time. And then one of the other things that we're seeing is we're seeing sort of changes in the way that land's actually managed. And I've put a photograph of a herd of sheep there, because one of the examples is that the numbers of animals on the land has actually gone up fivefold in the last 30 years. So there are 5 times more animals on any particular acre of land than there used to be. And the impact of that, and sheep are very effective at puddling the very top layer of the field. So they create compaction in the very top layer of the field, and that makes a very sort of hard, impermeable layer. So whereas the water, the rain, would land on a field and it would soak away and soak into that herb layer, it tends to, in more cases, hit a hard, compacted layer and sheet off the surface. You can also see differences in the way that we're cultivating with arable farms as well, and that can also lead to erosion, although it does also get complicated because sometimes ploughed fields can in fact be the most absorbent. But nonetheless, there are changes in agriculture and our land use that are leading to water leaving the ground very much faster. So what we do, and the way that we approach some of these problems, is traditionally we would see a flooding problem and we would stand in a village, perhaps Bourton or Colmington in the Corvedale, and we would try to think about how we would deal with the problem where the flooding is. So that's known as an end of pipe solution. And that tends to lead to digging more gullies and drains or building walls and hard defences in order to ship water away and keep it away from properties and that sort of thing. The approach that we take is known as the catchment-based approach, and it's gathering momentum across the whole country. And very much what we do is we look up into the upstream parts of the catchment and try to understand where the opportunities are to hold on to water for longer and capture water and get it to soak away and infiltrate into the land across a much wider catchment. That doesn't mean that it's instead of property protection or channel maintenance or culvert cleaning and those sorts of traditional things, but it's an extra tool in the toolbox, and it's another thing that we can use in order to add capacity to the system. So part of the jargon that we use is working with natural processes. So we're working in the catchment at this larger scale, and we're trying to work with natural processes. And all that means is we're trying to get the landscape to re-engage with some of the functions that it would have delivered beforehand. So infiltrating rainwater, getting it to soak away down into the land itself. You do that, you increase the permeability of the land, and again, it can get down into the soils and ideally down into those aquifers as well. Temporary storage can be things like pools or ponds, or even sometimes in midfield where you can hold it in using earth bunds and that sort of thing. Slowing flows, that can be across the land or in a water channel. Increasing roughness. So if you imagine pouring a glass of water across a hard concrete paving slab, it's going to sheet off that paving slab very, very quickly. But if you were to cover that paving slab in brush bristles, you would make it very, very rough, and the water would then take much longer to get from the top of the slab to the bottom. And in that way, we think about roughness in the landscape, and it might be at a large scale like trees, or it's actually a very small scale like simply allowing the vegetation to regrow on channel banks. We want to reduce sedimentation, so we want to try and remove the amount of soil erosion, the amount of sediment that's entering our watercourses, and we also want to improve the water quality. So slowing the rate of rainwater reaching the drainage networks prevents overloading, and as I say, helps to increase the capacity of those systems to manage at these times of flash flood and storm waters. So in the natural flood management toolkit, if you like, there's a whole range of different options. And as a practitioner, when I go out and about, I've got all of these things in my mind that are more or less suitable, sometimes depending on the topography of the land, sometimes depending on which part of the river system you're on, whether you're down in the floodplains or whether you're very high up in the headwaters of a river. And then also, what it allows us to do is to be quite flexible, because of course a lot of the land is, or mainly the land is farmed land, and there's other needs that we need out of that land. So there's a farm business that needs to remain viable, and there's food production that needs to happen in that landscape. So by having a very wide range of different options that we're able to use, we're able to tailor prevention methods and infiltration methods in such a way that they can actually fit with the needs and the wants of the farm business. And in that way, we can begin to find sort of truly sustainable interventions. So you can see from this image that if we start at the top of the catchment, sort of up here, we can look at things like woodlands and re-wooding up in the uplands. There's a digger up there on the peaty tops of the hills and blocking drainage ditches and things like that to get that sort of spongy woolly hat to come back on the tops of the hills. You can have wetlands that exist outside of the floodplain of watercourses, in-stream woody dam structures, storage ponds, fencing out livestock, which reduces erosion and encourages bank vegetation to grow back, bankside tree planting, pools, contour hedgerows, all sorts of different things that we can begin to look at. Um, so what I'm really looking for then when I'm walking through a landscape is I'm looking for where are those flow pathways, and where I can find a significant flow pathway, I'm very much trying to intercept that flow pathway, make it go a longer distance or capture it for a period of time. And it's very much about capturing water for a period of time and allowing it to drain away slowly, because we're not looking to flood farmland or flood other land necessarily permanently, because flooded land is full up. It's like a glass that's already full of water, and when the next storm comes, there's actually no capacity to catch any more water. So we want to capture it for a period of time, but we also want it to drain away slowly, so that when the next storm comes, there's more capacity in the system. So woody debris dams is another way of doing this, essentially, and I'm going to come back to these in a little bit more detail slightly later. But essentially what we're doing is we're recreating timber log jams in watercourses, generally very high up in the catchment. So we're not sort of thinking about the main river course, but we're thinking about those little brooks and streams and tributaries that are all leading down to the main river, where it can be much more appropriate, and when you often don't have that neighbouring land that you're worried about negatively affecting. We can also enhance river corridors. So you can see the image there really shows you some bankside poaching. This is where animals are getting down to the water's edge. And there's a number of things going on there. It's very, very smooth, so the water will go past it very, very quickly. There's no vegetation at that point, so the soil itself is not bound together in any way. So in times of flood, that will be scoured out, and a lot of sediment will enter the watercourse. An awful lot of sediment comes from the watercourse banks themselves, in addition to the stuff that runs off the off ploughed fields, for example. By fencing out livestock, you can improve water quality, because you're not getting animals defecating in the watercourse and adding various things. You will allow the vegetation to grow back, which will consolidate the bank and will also create that roughness I was talking about, which helps to slow down flows. And then there's the obvious biodiversity benefits of having that natural mix of flora on the river bank. Moving away from the river channel itself now, and looking to the fields and to the gullies and those flow pathways, contour and cross slope hedges or shelter belts. And a shelter belt really is a strip of trees. So it's like, imagine a very tall, very wide hedge, essentially. But what they can do is they can help to interrupt those flow pathways, and then we know that the action of tree and shrub roots work very effectively to help to transport water down into the deeper layers of the soil. So it actually removes water from the flow pathway, as well as interrupting it, creating roughness and diverting some of those flows, making it take a longer route, for example. Similarly, we can do tree planting along the edges of watercourses. So riparian simply means beside a watercourse, and there's a number of places where we've done this, where we know we've got known areas that flood, and so when the trees are established, it'll flood through those trees. The fact that they're there will help to hold water back just for slightly longer. Should be noted that each individual measure has a very small effect, but it's about looking at the catchment scale and trying to understand what the cumulative effect of all of these tiny little interventions is. So, to illustrate that, this is a map of one of the catchments, and what you can see is this is the watercourse running down the valley here, and what we were able to do is install a whole series. There's about 150, 200 woody debris dams. That's what each one of these little brown stars represents, all the way down the watercourse, and then beyond, almost down to the confluence of the main river. We've then also been able to plant some contour hedgerows in one or two places and do gapping up of contour hedgerows that will help to reduce some of those overland flows. Actually, at this point here, we've got a shelter belt, quite a wide, 12-metre wide shelter belt. There's another contour hedgerow there and down here. At this point, we've been able to do some track improvement, and then there's some plans afoot to try to co-opt this pool and get that to do some attenuation. So you can begin to see across just one very small catchment how a number of small, cheap interventions begin to add up to start to have an effect. And then you can actually widen that out some more to a larger catchment. And so what you can see here now, this is the Clee St Margaret catchment, and you can see that there's a number of tributaries running down from, some of it is fairly steep-sided, down into the Clee Brook. We know that we get flooding at Bolden and Peaton, and then quite a bit downstream at Colmington as well. And by putting in a large number of very small interventions, hedgerows, all sorts of dams, all sorts of things, we begin to have an impact on the speed that flooding occurs and the ultimate height of that flood peak in places like Bolden quite affordably. I mentioned contour hedges, so I'm not quite sure why that's appearing again. Moving swiftly on. Oh, that's right, I remember. Because there's ways of us calculating. So I have to try to provide value for money, and we can't always plant hedges everywhere where we might like to. So I need to try to work to find the most effective location for various interventions. So what you're looking at now is it's a bit of software called SciMap, and what it does is it uses soil type, slope data and rainfall data, and it combines them all together, and it helps us and it predicts where it thinks the major water flow pathways are going to be on the land. And so using this tool, you can see we opted for proposing contour hedgerows at this point and this point. And that was because, quite simply, there wasn't opportunity up here. On this branch, which is one of the other locations, there is already an established woodland, so we didn't need to do it up there either. And through a process of elimination with one or two other factors, we found that that was the best place where we could invest our money to put back a hedgerow to have the maximum effect for the downstream benefit. So, and I have a series of tools and different bits of data that I can rely on to help me work out what's going on the ground. Ultimately, there's absolutely no replacement for going and being familiar with the ground and walking it. There's a lot of legwork involved. One of the reasons that we know that some of these things work is because we rely on the data that has been gathered from other projects. So the Pont Bren project, which was in Wales, was a farmer-led project where they really wanted to put trees back into the landscape. And one of the things that they observed was that where they'd done tree planting, they noticed that surface water runoff was massively reduced, and they saw water almost disappearing into the field. And so they invited scientists from, I believe, Exeter University to come and have a look. And they did the science for the first time to understand how much water gets infiltrated down via the pathways created by tree roots. And we know that inside woodland now, that there can be 60 times greater infiltration than what you might experience in a normal pasture in a sheep field. And so that gives us some confidence in the work that we're doing and some confidence in the effectiveness of what it is that we're doing. So what I want you to do now is close your eyes if you want to, but imagine in your mind, just picture your ideal river. Picture the river that you think would be the most natural, sort of lovely river that you would like to visit. So just hold that image for a moment. I suspect that the sort of thing that you've got in your mind is this. A really lovely place to go for maybe a bit of a paddle and have a picnic beside, clear water, and a single channel, importantly. It may be meandering, but nonetheless a single open channel in a river. There is, in fact, something quite dramatic missing from our traditional image of rivers, and very few of us have actually seen a river in its natural, unmanaged state with the full complement of things you'd expect to find there. And the major component that's missing is this. It's wood. And there are very few rivers in the UK, if any, and there's only a handful of rivers in Europe now that actually still have their full component of what is known as large wood still within that watercourse. And you'd be expecting to find whole trees, large branches, big chunks of wood, about 10 times the width along a river. If you imagine 10 times the width of the river, you'd expect to be coming across some large timber like that. And these bits of wood have really important functions. They create a large amount of complexity in the channel. They create gravel bars, they create pools and chutes. The material itself acts as a physical anchor for some animals and wildlife, as well as providing food. If you're a fish, if you imagine that you're just in an open channel and the water is pouring through all the time, you've got to swim against that flow to maintain your position. Now imagine that you're trying to eat insects in the flow, and so the insects are whizzing past you ever so quickly and you're trying to grab them. Now imagine that there's a lot of sedimentation in that water, so you can't even see the insects until they are centimetres away from your mouth. And you begin to understand the sort of challenges that you have as a fish living in these systems. By adding lots of wood, you create little backwaters, slowed flows, pieces of timber that they can get in the lee of. They can sort of rest out of the flow behind them. There's more insects in the system. It's helping to drop out that sediment. So trees can be really looked at, and trees and timber can be really looked at as engineers of the ecology and habitat of a river. So we essentially have started recreating some of that stuff artificially by building these woody debris barriers that will hold back water at times of flood, but at the same time will allow water to pour through them. And in times of non-flood, the river returns to being flowing and acting as a drainage channel as normal. Of course, we're constructing them, so we actually have a method of constructing them, and we have ways of fixing them in the channel so that they're not just going to haphazardly cause problems and get washed out and cause damage. So we have a whole risk assessment about understanding exactly where we position these things. And these are examples, approximately 400 or so out in the Corvedale now, so I've built quite a lot. I'm just going to scroll through, and you can see with each of these, you can see the water built up upstream behind these structures, and you can see the water flowing through, how it's not interrupting fish passage and other things, but it's also helping to catch material, drop sediments out. This image shows you how it's created clean gravel just immediately downstream of the timber, and that's a really good, well-oxygenated place where fish can lay their eggs and that sort of thing. It creates complexity in the channel, chutes in this case, or pools in this case. And even quite small pieces of timber can hold back water quite a surprising amount. Sometimes the timbers that we use, however, can be very, very large, and there's some opportunity for putting some big pieces of wood back into water channels. So, big question, does it work? Well, there is still more for us to find out, and we're doing a lot of monitoring with the work that we do in the Corvedale, but the initial indications are very, very good, and we're working from the data that's been gathered by a whole load of other projects. The first major project to use natural flood management techniques really was Pickering, one of the most famous after some horrible flooding that they experienced. And we do find that installing 100 plus leaky barriers can reduce flood flows by significant measurable amounts. And if we give a homeowner an extra half an hour before that flood peak hits, or if we reduce that flood peak by just a few centimetres, that really can be the difference between tens of £1,000s worth of damage and getting away with it. So we think it's a very worthwhile thing to do. You can also see the amount, the volumes of storage on some of these structures, and you can see one of our monitoring posts in the foreground there. We have a whole load of monitoring gauges in the catchment, from rain gauges and level boards. Cardiff University are working with us to do a study around the effectiveness of the leaky woody dams, and we are doing some fixed point photography and other measures to actually start to get some really good hard data and actually really quantify the amounts of water we're holding back and for how long, and therefore for every pound of money that we spend, how much flood benefit are we actually having. And again, it's just worth reminding that although the focus is flood benefit, everything that we do, and because we're working with these natural systems, we have these additional benefits. We're improving habitat and biodiversity, we're improving water quality, we're reducing animal disease transmission, and we're reducing erosion and soil loss, which, going back to the numbers at the beginning of the presentation, you can understand these are all cost-effective benefits to society at large and also to the wider environment. That is the end of my talk. So I would like to thank you very much for listening, and I hope you found it useful, interesting, informative. I'm just going to flick back so that you can see my face. Hello, I think I'm back. I'm just looking to see if there are any questions. Just opening up my email. Okay, so just one question is, how do we get large pieces of timber into place? Essentially what we do is we use the trees that are already growing beside the watercourse, and that actually can be a useful part of the watercourse management, because you don't just want a mature canopy, you actually want different stages of trees that have been recently coppiced to trees that are right up to that mature canopy. So we fell trees as close as possible to where we want to build one of these woody barriers, and we construct it in situ essentially. And I've got contractors who generally they're using hand winches and hand chainsaws, so it's all kind of handballed in channel. I hope that answers your question. I'm not seeing any other questions coming in at the moment, so perhaps we'll just give it one moment. Okay. Well, I think all it remains for me to say then is thank you very much for listening. I hope you found this useful. My name was Neal. I work for Shropshire Wildlife Trust. Thank you very much.